And maybe at the bottom of page 344, we can add these two graphs. So these are similar to what you saw in 5.1. If you had to graph y equals 3 to the x, you have an asymptote at y equals 0. You have the point 0, 1, and because the base is 3, you'd have 1, 3.
I think you're muted.
I am muted. Thank you. That's a good thing. First part of that video where I'm swearing at all of you is not going to be on. Right? From now on, if I get mad, I'll just have to use hand gestures. I mean, you could find other points. Is it hard to plug in 2 and see that this is going to be 9? No. But you only need 0, 1, and 1, 3. Same thing if you had 1/5 to the x. You'd have 0, 1 again, and if I plugged in 1, I would have 1, 1/5. You still have the asymptote at 0. So could we have included this in our very first chapter, chapter 3, and done all the transformations? Absolutely. It's not crazy new parent graphs. However, it's kind of nice to take a break from that and then get built-in review. We're going to get built-in review of chapter 3 in this unit because we're going to graph all of the transformations with exponents. The one thing that makes this a little bit trickier is it has a number in the parent graph. And so sometimes that can cause confusion because you're used to all of the numbers being things that move things left, right, stretched, compressed. Now one of the numbers is part of the original graph. So sometimes that's a little bit hard on our brains, but we can go to example 1. It says graph y equals 1/3 x. So in graphing an exponential graph, I like to start by drawing my asymptote because they all have an asymptote at y equals 0. Then I label the point 0, 1 because every exponential graph has 0, 1. And this one, the base is 1/3. So when I plug in 1, I'm going to get 1/3. Which means our graph goes down. Question?
So if you in the other asymptote unit or whatever, if you curl the line up, that's still
Yes, I was gonna, you know what? It's perfect that you say that. Because I was just going to say, now that you've all copied my graph down, check your graph. Because I don't know why it is, but did any of you accidentally curl it up at the end? You will lose an E10 mark. Check your graph. You were copying it, but I don't know why it is at the end there. Your hand wants to go up. It's so tempting. So if your graph did what the green graph does here and swooped up, you would get an E10 because you're now getting further away. So you want to be careful with asymptotes that your graph is getting closer and closer, not going through, not touching, but not swooping up at the end. And yeah, something like, oh, I want to just go to the next question. Your hand will just naturally swoop up. I don't know why. Okay, so now we can answer these questions. What's the effect on y when x increases by 1? Well, if x increases by 1, we got 1/3. If it would have increased by 1 again, we would get 2,19 each time your x goes up by 1, your y gets multiplied by 1/3. That's what an exponential function does. Keeps multiplying by the same thing over and over again. Is this one increasing or decreasing? Well, it's going down from left to right. It's decreasing. We have no x-intercept because of the asymptote, but we do have a y-intercept at 0, 1. The asymptote is at y equals 0. The domain is everything. The range is bigger than 0 but not equal to 0 because of the asymptote. Could circle questions 3, 5, and 7.